So what is our first step?
Set equal to 0.
Set it equal to 0. So we're going to have 2 cosine to the 4th x minus cosine squared x equals 0. And then we're going to factor that. So it's 2 terms. What's my first step of factoring always? Is there a greatest common factor? So I'm going to divide out, not divide out, but factor out that cosine squared x. I'm going to put it in front of a parenthesis. And then what I have left over is 2 cosine squared x minus 1. If you can distribute that cosine x squared back in and it equals the original one, then you've factored it correctly. Go for it. I try to factor 2 cosine squared x minus 1 further, but it doesn't. So I factored it as far as I can factor. So I'm going to set each factor equal to 0. So I've got cosine squared x equals 0. I'm going to square root both sides, put in a plus minus, but it doesn't really matter because it's 0. Where is cosine x equal to 0? Pi over 2 and 3 pi over 2. On the other side, I'm going to square root both sides. So I'm going to put in a plus minus. And I get cosine x equals plus minus, and then I've got radical 1 over radical 2, so I've got plus minus 1 over radical 2, which I rationalize. I have plus minus radical 2 over 2. Where is cosine plus or minus radical 2 over 2? That's all the pi over 4, right? So then I'm just going to take all of the answers that I found, which are 6 of them, and I'm going to put them in order. And if you're not sure what order to put them in, you could graph them. There's the pi over 4s, and then my pi over 2 and my 3 pi over 2 are here and here. So we're going to put them in order, going around the circle. X equals pi over 4, pi over 2, 3 pi over 4, 5 pi over 4, 3 pi over 2, and 7 pi over 4. Anyone see the graph? Yeah, okay. So that one was, oh no, which one was it? This. Is it the third one we just did? Which example is it on there? Oh, it's the one that, yeah. That's this one. So, Desmos won't let me put in a 4th power, so I had to write cosine squared times cosine squared. It is that one. So that's what the graph looks like. I'm going to change the y's. I didn't really help much. I can kind of see it better. So between 0 and 2 pi, it should have 6 answers. So I'm clicking on those answers and checking to make sure our order is correct, that we have all the correct answers. Okay, can you try this one on your own, please? Try it. You can do it on your own? you. To get x factored, you should have 2 cosine x plus 1 and then cosine x plus 1 to solve each factor. I get down to where is cosine x negative a half? It's going to be here and here at pi over 3, so 2 pi over 3 and 4 pi over 3. And then where is cosine negative 1? Just at pi. We've got 3 answers. Put them in order. 2 pi over 3, pi, and then 4 pi over 3. I have a draft for you. So that's what this one looks like. 3 answers between 0 to 2 pi. Does that one look like a fun roller coaster? Okay, next one. Is it equal to 0 first?
Yes.
Okay, if it's equal to 0, then I can factor it. How many terms does this have?
4.
It is 4. It is 4. So terms are separated by plus or minus signs. So we've got four terms. These we're going to use factor by grouping. Group the first 2 and the last 2. You have a plus sign in between, and then you factor each parenthesis separately. So I look at my first parenthesis, and I think about factoring, which starts with GCF, and there is a GCF. So I'm going to factor out secant x. So I'm going to have secant x, parenthesis, or cosine squared x minus 3. In my other parenthesis, GCF, there's a 2. So I have plus 2, parenthesis, 4 cosine squared x minus 3. If you're doing factor by grouping, we need to be able to factor it further. After you take something out like that, you need to be able to factor it further. And at this point, we have 2 terms. We have 2 terms right now. So then we think about factoring the 2 terms. What are our choices for factoring 2 terms? First thing is always GCF. So we're going to look at the 2 terms. Is there something in common?
Yes.
That thing in parentheses, 4 cosine squared x minus 3. So I'm going to factor that out. That's my now GCF for my 2 terms. So it cancels out there, and I have 4 cosine squared x minus 3. And then what's left over is secant x plus 2. Well, once you do the factor by grouping, then you look at what's left as a new factoring problem. And there's 2 terms. So we start factoring over again. We always look for GCF first.
Okay. So is that just the step in between? So like last year, like all we did was just like from that, we just go straight to that. Is that like an in between step?
Well, this, I know what you're saying. This is how you get to this.
Yeah.
So your teacher might have just said, do this. But then I explain why.
Yeah, and they just said take the first in the middle.
Right.
Yeah.
So the reason why that works is because the thing in the parentheses becomes a GCF.
Okay.
And we're undistributing that GCF.
Right.
So that's why that works.
Yeah, it's just kind of like, since they're the same, just.
If you're doing it right every time, then I'm not worried about you. I have people that take this out and make it squared. Because there's 2 of them, but that's not what it is. Because they didn't understand it. Okay. All right, so now we have it factored, so we're going to set each factor equal to 0. So we have 4 cosine squared x minus 3 equals 0. And secant x plus 2 equals 0. I'm going to solve each of these. 4 cosine squared x equals 3. Cosine squared x equals 3/4. X equals -2. When we have a squared, we're going to square root, so that means plus minus. That was supposed to be a different color. And I'm going to square root the 3 and square root the 4 separately, so I get square root of 3 over 2. I know I went fast. If I'm going too fast for you, the notes will be okay. That's the long of the video. If I push record, I think I pushed record. Pretty sure I did. Okay, so now where is cosine positive or negative radical 3 over 2? All those pi over 6. Yeah. And then where is secant -2? And if you don't have your secants memorized, change it to cosine. Where is cosine -1/2? 2 pi over 3 and 4 pi over 3. So we've got 6 answers, and if you need to graph them to put them in order, feel free. So it'd be pi over 6, and it'd be 2 pi over 3, 5 pi over 6, 7 pi over 6, 4 pi over 3, 11 pi over 6. How come your teacher can just go so fast? No, this is my second year teaching.
Practice.
Practice. I didn't do it. It's because I practice. You can be that good too. You just gotta put practice. Want to see the graph? Okay. Oh, I'll go back to it if I went too fast. Look at this graph. Look at this one. Woo! What does it look like? Oh, teeth. But anyway, if I look from 0 to 2 pi, here's 0 to 2 pi. I have 1, 2, 3, 4, 5. Oh, I gotta zoom in. They're overlapping each other. I've got 1. Try to get 1, 2, 3, 4, 5, 6 answers from 0 to 2 pi. Last one. What should we do first? Set it equals 0. Do it. This is my least favorite one to do also. You know why? No, because I have to write cosecant like a bunch of times, and I always mess the letters up. I always put the F first. Gotta have it. Gotta actually take my time to write this one. So 4 terms, we're going to do grouping. There has to be a plus sign in between if you want to do grouping. Yeah, you change it to plus to negative, and you put the negative inside of the group. And then we factor out the GCF from the first group, which is cosecant squared x. I just can't talk and write cosecant at the same time. So I'm left with cosecant x minus 2. Other parentheses, I'm going to factor out the -1. And I'm left with cosecant x minus 2. So then I ask, we now have 2 terms. Is there some sort of greatest common factor between my 2 terms? that cosecant x minus 2 is now what I'm undistributing. What I'm writing right here, now I'm doing it yellow because I don't normally write it every single time. And your teacher didn't write it last year, but this is why it's factoring that way, because I'm factoring it out. And then what's left over after I cancel those is cosecant squared x minus 1. Can anything factor further?
Yes.
Yes. That second parenthesis in factoring, what is this called, the second parenthesis? These are difference of squares, difference of two squares. So this is cosecant x plus 1 and cosecant x minus 1. And then I'll bring down cosecant x minus 2. We have three factors. We'll set each of them equal to 0. Let's solve each of these.
What did you just set the original?
You could. This one, right? This
Yeah.
one. Yeah, you could, but I wanted to show you that you also can do different
I don't
stuff.
know if you like take off or
No.
missing step.
No, because you're going to still get the answer. It just, I guess if it says factor it completely, then I would want the red one. If it's just solve it, and your option is to do it by factoring, you can kind of solve however you want. Okay, so I don't have my cosecants memorized, but I have my sine. So I'm going to think what sine is, where sine is a half, which is 5/6 and 5/6. And then sine, where is sine -1? 3/2. And where is sine 1? 5/2. So I have 4 answers. In order, 5/6, 5/2, 5/6, and 3/2. You like see, like imagine where those are on the graph, on the what's this called? Unit circle. Want to see the graph? Let's look at the graph. There it is. Got some more teeth for you.
It's like a multi-gene, but it's all.
Teeth and a tongue, I guess so. Okay. So, if you need to see any more of these notes, if I went really fast on it, you need to go back and see it. You can totally ask. I can go back to whatever page you need. And the assignment for this one is a second worksheet, which I'm passing out now. I'm going to go ahead and stop the video.